Foundations of Amateur Radio. A little while ago, I mentioned in passing that I was considering implementing a Parrot Repeater to help determine how your radio is performing. Discussion afterwards revealed that not everyone had the same picture in mind, so I thought I'd share with you some of what I'm considering and why. Most of the modern radio landscape revolves around hooking a computer up to some type of radio frequency-capable device. Commonly, it's the audio and control signals that travel between computer and radio, but there are plenty of examples where raw data makes the journey, like in the case of an RTL-SDR dongle. That journey is increasingly made using USB, the cable, not the sideband, and limits are based around the maximum speed that a universal serial bus has. Essentially, the amount of data that you can process is limited by how fast your computer can talk to the radio. For my Parrot Repeater, I'm imagining a device that can receive RF from any radio and process that signal to determine what the center frequency is, the deviation, the stability, the mode, whatever parameters I end up being able to determine. A whole other discussion on its own. In response, the idea is that the device generates a report and either presents that using text-to-speech or as a web page, or both. Using traditional methods, this would involve a radio, a computer, some software, connections between the radio and the computer, not to mention power for both the computer and the radio, an antenna, and perhaps an amplifier. The picture I have in mind is not anything like that. I'm imagining a single device that takes power and does all I've described inside the one device. No external computer, no audio cables, no control cables, no hard drives, not anything. Just a Pluto SDR and a power source connected to an antenna or two. You might think that's fanciful. As it happens, we already have some of that today. When I run Dump 1090 on my Pluto SDR, it presents itself to the world as a website that I can visit to see which aeroplanes are within range, where they are exactly on a map, what messages they're sending, and where they're going. All of the processing is done inside the Pluto SDR. All I have to do is give it power and an internet connection. This is possible because the Pluto SDR is essentially a computer with RF. It runs Linux and you can write software for it. Unlike my Yaesu FT857D, which also has a computer on board, rudimentary to be sure, but a computer nonetheless, it cannot be altered. I cannot load my own piece of software, launch a web browser and point it at my Yaesu, not without connecting an external computer that in turn needs to be connected to the radio. I might add that this is how many repeaters work and how devices that implement All-Star and Echolink manage to make the jump between the internet and the world of RF. If your eyes are not lighting up right now, let me see if I can put it in different terms. The Pluto SDR has the ability to access signals between 70 MHz and 6 GHz. It can do so in chunks of 56 MHz. Said differently, if you were able to consider all of the amateur HF spectrum from 0 to 54 MHz, you could fit all of it inside one chunk of 56 MHz that the Pluto SDR is capable of. You couldn't send it anywhere since you're limited to how fast a USB cable is, but you could technically process that inside the Pluto SDR itself. To get the Pluto SDR to see the amateur HF bands, you could connect it to a transverter in much the same way that today many 2-meter handheld radio owners use a transverter to get to 23 centimeters, except in this case we're going the other way. In order to actually use this massive amount of information, you're going to need to do some serious signal processing. Accessing 56 MHz of raw data is hard work, even if you don't have to get it across a serial connection. As it happens, the Pluto SDR also comes with an FPGA. As I've mentioned previously, it's like having a programmable circuit board, which can be programmed to do that signal processing for you. It has the capability to massage that massive chunk of data into something more reasonable. For example, you might be able to use it to extract each of the amateur bands individually and represent them as an image that you might show to the world as a waterfall on a web browser. Now, to be clear, I'm not saying that any of this exists just yet, or fits within the existing hardware constraints. I'm only starting on this journey. I'll be learning much along the way. No doubt I'll be using existing examples, tweaking them to the point that I understand what they do and how they work. I've already been talking about some of this for years, As you might have discovered, this adventure is long with many different side quests, and at the rate I'm going, I'm confident that this represents the breadth and depth of what amateur radio means to me. So if you're wondering why I'm excited, it's because the amateur radio world of opportunity is getting bigger, not smaller. I'm Ono, Victor Kilo 6, Foxtrot Lima, Alpha Bravo.